So dear students, in this video we are going to study a new topic, and that is Gauss law. So firstly I want to write the definition of Gauss law. States that statement states that the total electric flux through any closed surface is equal to the charge enclosed by the surface divided by the free space permittivity. The total electric flux through any closed surface is equal to the charge enclosed by the surface divided by the free space permittivity. Mathematically, it can be written as phi, which is the total electric flux, equals to summation closed surface integral integration over closed surface E dot ds. This is the electric flux through the closed surface. Total electric flux through the closed surface will be equals to charge enclosed by the surface, if Q is the charge enclosed by the surface, divided by the free space permittivity, divided by epsilon 0. So total flux through any closed surface is equals to Q by epsilon naught, charge enclosed by the surface divided by free space permittivity. So this is our Gauss's law. Okay, this quantity, you might be confused about this quantity. So this is nothing but this is the net electric flux through any closed surface. So okay, I will explain this particular surface integral now. Let us assume a spherical closed surface. So this is my spherical closed surface. In this case it is spherical, so spherical closed surface. So it is known as, in this case it is known as Gaussian surface. Gaussian surface. So this Gaussian surface I have taken spherical closed surface, remember, and let S be the total surface area of this closed Gaussian surface, and let Q be the charge enclosed by this surface at the center of the surface, or Q be the charge enclosed by this closed sphere at its center. Now my wish here is to calculate what is the net electric flux that is flowing outside this closed spherical surface. So for that I will take small surface element ds. So ds is nothing but it is a small part of this spherical surface, ds, and let ds is directed towards this direction. So this is the direction of the ds, outward normal. This direction is perpendicular to the surface itself. So this is the direction of the surface. Previously in the discussion of electric flux, we have given some direction to the area vector. So this ds is nothing but it is the area vector in this case. So this is my area and this is my area vector. ds is the magnitude of the this area vector, and ds vector is the direction of this particular area vector. Now we know at this particular area this q will contribute some electric field, or at every point on this area there is a net electric field flowing out of the surface. For example, there is an electric field flowing out at this point due to this positive charge. There will be some electric field flowing out this point due to this positive charge, because for positive charge all the electric field lines will outward. It will be going outward from this positive charges. So that means at every point on this surface there is a electric field which is going outside. And even at this point, at the point of this particular ds area element, there is an electric field going out, and it is let it be e vector. E vector is the value of the electric field at this particular surface, and whose direction is parallel to the direction of this particular ds vector or small area element. This ds is nothing but it is small area element. Small area element. And let r be the radius of this sphere, Gaussian surface. Let r be the radius of this particular spherical closed surface. Now I want to calculate what is the flux flowing through this particular ds element. So flux through this particular ds element will be nothing but, we have the formula for this, so it will be E dot ds from the definition of electric flux. So flux flowing through this particular ds element will be E dot ds. Now ds and E are directed along the same direction. That means there is 0 degree angle between this ds and E vector. Therefore E dot ds will give me E ds cos of theta. So theta will be 0 in this case because E and ds are the same direction. So E ds cos theta will be cos of 0, which is nothing but which is 1. So phi ds in this case will be just E ds. So flux through this small area element will be E into ds. Now my wish here is to calculate what is the total flux. My wish here is to calculate what is the total electric flux through this whole Gaussian surface or through this whole spherical surface. So all we have to do is to integrate this particular flux through this small area element for the whole surface, and that integration is known as surface integral. If I integrate this ds along its whole surface, I will get the total electric flux through this particular Gaussian surface. So net flux through the whole surface will be phi s. Phi s is the net electric flux flowing out through this whole surface will be surface integral, closed surface integral of this phi ds. If I integrate this phi ds along its whole surface, I will get total flux through the whole surface. That will give me phi s is equals to closed surface integral of, now phi ds is nothing but it is E ds. Now we know at every point on the surface, the value of the E are same because it is equidistant from the charge q. All the points on the surface lie at the same radius from the charge q. That means at every point on the surface, the value of electric field is same. That means this E is a constant and it comes out of the integration. Therefore, phi s will be E comes out of the integration. So it is just surface integral of ds. So now what is the surface integral of ds? What is the value of ds if we integrate it on the whole surface of the sphere? If I add this ds along the whole surface, what I will get? ds is the small area element. So I'll get the total surface area of this sphere. And the total surface area of the sphere is s, because if I add all ds along its surface, I'll get s. So if I integrate ds throughout the surface, I'll get phi s is equals to E. So integration of ds along its whole surface will give me the area of the surface itself, which is s. So this will give me phi s is equals to, now what is the value of the electric field at each point on the surface? If q is the charge and each surface, and if q is the charge and each surface points are r distance from the charge, so at each point on the surface, the value of the electric field will be q divided by 4 pi epsilon 0 r square into, what is the surface area of this whole Gaussian surface, which is a sphere? So the surface area of the sphere is nothing but it is 4 pi r square. So here what things will get cancelled? 4 pi will get cancelled, and r square will get cancelled. So all the things are remained are q and epsilon naught. So q divided by epsilon, which is nothing but the definition of Gauss law itself. So Gauss law, earlier we have defined Gauss law as the total electric flux through any closed surface is equal to the charge enclosed by the surface divided by the free space permittivity. So total flux through, net flux through the closed surface, S is nothing but it is the charge enclosed by the surface, which is Q divided by the permittivity of the free space. So this is known as Gauss's law in mathematical form. This is your Gauss's law. Now there are some assumptions of this Gauss's law. So assumptions I want to discuss briefly. So first assumption is the direction of electric field and area vector. So electric field is E vector and area vector is ds vector, have to be the same. So this is one of the assumptions. This E and ds should always be along the same direction. And the second one is the Gaussian surface should have some symmetry. Should have some symmetry in them. Meaning your Gaussian surface should be a symmetrical surface, which means that if the surface is symmetrical, then only the value of the electric field at each point on the surface will be same, E. That's how we taken E as a constant. If your surface is not symmetrical, let us take, if it is a cubical or cuboidal, then the distance from the center of the cuboid to each point on the surface will not be same. In that case, E will not be constant and you cannot utilize Gauss law in that case. So there should be some symmetry in the surface also. I think that's it for Gauss law. Thank you.